Today we will find the sum from 1 to infinity of 1 over n squared. And to start off, we will consider the Fourier series of f of x equals x squared on their interval from minus pi to pi. And the function is given by f of x equals a naught over 2 plus the sum from 1 to infinity of an cosine nx plus bn sine of nx, where a naught over 2 will be 1 over 2 pi, the integral from minus pi to pi of x squared dx, and an will be 1 over pi, the integral from minus pi to pi of x squared times the cosine of nx dx, and bn will be 1 over pi, the integral from minus pi to pi of x squared sine of nx dx. So now from here I will consider a naught over 2. So we'll calculate this Fourier coefficient first. So we said this is 1 over 2 pi, integral from minus pi to pi of x squared dx. But since the function f of x equals x squared is even, we could write this as 2 over 2 pi and then the integral from 0 to pi of x squared dx. These divide to 1. We have 1 over pi, the integral from 0 to pi of x squared dx. Integrating this, we have 1 over pi x cubed over 3 from 0 to pi, which is equal to 1 over pi and then times pi cubed over 3, which simplifies into pi squared over 3. So we have a naught over 2. The first Fourier coefficient is now going to be pi squared over 3. And the next thing we have to calculate is an. So an is 1 over pi, the integral from minus pi to pi of x squared cosine of nx dx. And we'll analyze the function f of x equals x squared cosine nx by plugging in negative x. So f of minus x is negative x squared cosine of negative nx, which is equal to x squared, and the cosine is an even function, so we have a cosine of nx, which is the original function. So we have f of minus x equals f of x, so this means that f is even, and because of that we could write an equals 2 over pi, the integral from 0 to pi of x squared times the cosine of nx dx. And to calculate this, we'll use integration by parts, but we'll use the tabular method. So here is d and here's I, where d is for differentiation and I is for integration. And we're going to be differentiating x squared and integrating cosine of nx. So taking the derivative, we have minus 2x and then plus 2 and 0, because you have to alternate the signs. And the integral of cosine of nx will be 1 over n sine of nx. And the integral of sine will be minus 1 over n squared cosine nx. We're going to have a minus 1 over n cubed term, and then the integral of cosine is positive sine. So now from here we multiply the diagonals, and we see that an equals 2 over pi. We're going to have a x squared over n sine nx. Negative and negative will make a positive, so we have plus 2x over n squared cosine of nx, and then positive and negative make a negative, so we have a minus 2 over n cubed sine of nx from 0 to pi. So an equals 2 over pi, plugging in x equals pi, we have a pi squared over n sine of pi n plus 2 pi over n squared cosine of pi n minus 2 over n cubed sine of pi n. And if you plug in 0, x equals 0, all the terms will just end up canceling. So we just have this expression now. And we'll notice that sine of pi n equals 0, where n is an integer, and the cosine of pi n equals negative 1 to the n, where n is also an integer. So because of that, this will cancel and this will also cancel. So an equals 2 over pi times 2 pi over n squared cosine of pi n, and the pi's cancel. We have a 4. Cosine of pi n is negative 1 to the n over n squared. So we have an equals 4 times negative 1 to the n over n squared. And now from here we'll calculate bn. So we said bn is 1 over pi, the integral from minus pi to pi, x squared sine nx dx. So we'll do the same thing similar to the cosine function. We'll analyze f of x equals x squared sine of nx, and now we'll plug in negative x. So f of minus x equals negative x squared sine of negative nx. We have a x squared, but sine is an odd function, so the negative goes out front, sine of nx, which is negative of f of x. So this means that f is odd. But since the function is odd and we're integrating over a symmetric interval, bn must be 0. So now from here we have all the Fourier coefficients. So we said that a naught over 2 equals pi squared over 3. We said that an equals 4 negative 1 to the n over n squared, and bn equals 0, where our function is f of x equals x squared, where x is on the integral from minus pi to pi. So recalling the definition of our function, we have that f of x equals a naught over 2 plus the sum from 1 to infinity of an cosine nx plus bn sine of nx. So our function, we said it's x squared equals a naught over 2 is pi squared over 3 plus the sum from 1 to infinity. An is 4 negative 1 to the n over n squared cosine of nx plus bn is just 0. And now all that's left to do is let x equal pi. So if we do that, we have pi squared equals pi squared over 3 plus the sum from 1 to infinity of 4 negative 1 to the n over n squared. And we'll have a cosine of pi n term, but we said that's negative 1 to the n for n is some integer. And we have 2 negative 1 to the n, so negative 1 to the n times negative 1 to the n is negative 1 to the 2n, which is negative 1 squared to the nth power, which is 1 to the nth, and 1 to any power is 1, where n is an integer. So we have pi squared equals pi squared over 3 plus the sum from 1 to infinity of 4 over n squared. Now all that's left to do is solve for a goal sum. So we have pi squared minus pi squared over 3 equals 4 times the sum from 1 to infinity, 1 over n squared. This will end up simplifying into 2 pi squared over 3 equals 4, the sum from 1 to infinity of 1 over n squared. And all that's left to do is multiply it by a factor of 1/4. So the sum from 1 to infinity, 1 over n squared equals 2 pi squared over 4 is 2 times 2, and then times the factor of 3. These two divide to 1, and 2 times 3 is 6. We have pi squared over 6. So now we could say that therefore the sum from 1 to infinity of 1 over n squared is equal to pi squared over 6. And so this is the final result. Thank you very much for watching.